and today we're in another episode of differential equations. First order differential equations and third type exact equation. Okay, so these are equations. For exact equations, these are equations who have differential of which we can say that the differential of m with respect to y is equal to the differential of n with respect to x. Okay, so exact equations have their left and right side equal if differentiated with the other variable. Okay, so what are we talking about left and right side? Okay, so first of all, this is what you call test for exactness, or this is basically the equation that will say if your equation is exact. Partial derivative of m with respect to partial derivative of y is equal to partial derivative of n with respect to partial derivative of x. Okay, so first we need to understand what is m and what is n. Okay, we see the equation as m dx plus n dy. So basically, we distribute the equation into dx and dy term. Okay, and whatever on the side of dx is m and whatever on the side of the dy is n. Okay, in this equation, m is t2xy and dn is equal to x squared plus y squared. Okay, and we differentiate m with respect to y. Okay, when we differentiate with respect to y, we only focus on the y variable and we consider the x variable as constant. Okay, so you could call this a half differentiation or half differentiation. Okay, so we consider the other variable constant. Okay, so this will become 2x. Okay, the y got differentiated. You could also put here differential of 2x differential of y, which it will become 2x. Okay, then n with respect to x. Okay, we will now differentiate only x. Okay, so on the y squared case, this one, I'm gonna zoom in a little. Okay, on the y squared case, we put y squared because y squared is considered constant. Basically, there's no x variable on the second term. Okay, plus differential of x squared. Since on the second term there's no x variable, only constant y squared, it's gonna be 0 plus x squared, it's gonna be 2x. Okay, it's gonna be 2x. Okay, now you can see that m of y and n of x are both 2x. Therefore, we could say our equation is now exact. Okay, and that is test for exactness. Basically, that's the test for exactness. Okay, when the m of y or the differential I'm getting tongue twisted. Right, partial derivative of m with respect to partial derivative of y is equal to the partial derivative of n with the partial derivative of x. Okay, is equal. It is exact. Alright. Hope you guys understood what's the test for exactness is. Okay, so this is what you call test for exactness. Okay, but how do we solve for the exact equation? Alright, so let's go for solving. So actually, solving for exact equation has three ways. Right? 3 ways. Okay, so first we're gonna solve it by integrating the left side m dx, right, and integrating n dy. Okay, notice that if we have an equation, differential equation of m dx plus n dy, okay, m dx and n dy can be considered If that's an exact equation, MDX and NDY can be considered two parts of a product rule. Because when we say a product rule, let's say XY, product rule, your XY will be differentiated as Y dx plus X dy. So basically, it's a two parts of product rule. And we integrate left and right side both in order to see, okay, what will be the general solution will be. Okay? If we integrate M once, and if we integrate N once, we can analyze what will be the general solution is. Okay? So for example, we have 2xy. Right? For M, we have 2xy. So in half integration, we're gonna put 2y here and integrating x dx because we're only focusing on x now. Okay? And for y square, we have x square y square. So we're gonna, for y square, for n dy, we're gonna focus on the y. So x square integral dy plus integral y square dy. Okay? Because we're only on the mdx, we're focusing on the x, and ndy, we're focusing on the y. Integrating both sides, we're gonna have y x square. Okay, y x square. On the bottom one, we're gonna have x square y plus y cube. Okay, over 3. Okay, here's the additional part. Okay, when we integrate mdx, we add f of y and g of x. Okay, so if we have a product rule, okay, we differentiate the two variable. We differentiate the two variable x plus x dy. We differentiate y first. X dy plus y dx. By means of half integration or half differentiation, when we differentiate in respect to y, we consider the x as constant. Okay? And if we have values, let's say x plus xy, if we consider x as constants, there's gonna be x terms that doesn't have y. Okay? They're gonna be differentiated and they will become 0. Okay? So the f of y and g of x are basically the terms that compensate for the constants that disappears when you differentiate or half differentiate with only one variable. Okay? So for example, what we did before, right? We differentiated with x, right? Or we differentiated with y. If we have an x constant, or if we have an x without a y, it will be considered a constant and it will become 0. It will disappear. For example, is this one. The y squared disappeared because there's no x. Right? Differentiated with x. Right? So the reverse engineering the process, we now compensate with f of y and g of x for basically the terms that disappear. Right? The terms that disappear because of differentiating in terms of x, and the terms that disappear, okay, for differentiating in terms of y. Okay, so in this case, our general solution will be, okay, let's go to the general solution. We're gonna copy the common terms, x squared y. You see there's like common terms in the equation. Okay, common term x squared y. Okay, plus, okay, let's identify f of y as y cubed over 3 and g of x as 0. Okay, so meaning in our general solution, there is a y term or y cubed over 3 that disappeared when it got differentiated in terms of x. Okay, it disappeared when it got differentiated in terms of x. So when you differentiate in terms of x, the mdx1, the y cube disappeared. But when we differentiated with in terms of y, it become y squared. Okay, so y cube plus 3, while g of x is a term containing only x, but since there's no, because in the mdx and ndy, there's no term containing x, it's now, g of x now is 0, meaning there's no term of x value only. Then we're gonna put constant at the end. Okay, this is now our general solution. Okay, this is now our general solution. We could simplify it by multiplying to 3. By multiplying the equation into 3, we can simplify it. X square y 3 plus y cube is equal to c. Right? This is now our simplified general solution. Okay? We're gonna do it again. Okay? We're gonna do it again. Let's solve another one. Okay? Let's solve another one. So what we did here, we're gonna repeat this process. Okay? So how about let's solve for number 2. Let's solve for number 2. First, let's test for exactness. Okay? Identify m first. M is the terms beside dx. Xy squared plus y minus x. N is equal to x squared y plus x. Okay? And m with respect to y is 2xy plus 1 minus 0. The negative x will become 0. And with respect to x, that's not 2. Okay, I wrote the partial derivative. Looks like 2. It looks like 2. Okay, so x squared y, we're gonna focus only on x. It's gonna become 2xy plus 1. Okay, therefore they are exact. Okay, we differentiate m with respect to y, and we differentiate n with respect to x. Okay, next, solve. Okay, we integrate both left and right part, right? Both. Right, so mdx, we integrate this side. Right, we integrate this side first, the red side. Integrate the right side, and the green side, the right side. Right, left side, right side. Right, so mdx, we're gonna be focusing only on x. Okay, y squared integral of x dx plus y integral of dx minus integral of x dx. Okay. Okay, then integrate y squared x squared over 2 plus yx minus x squared over 2 plus f of y. Okay, we add fy denoting the y terms that disappear. Basically, this is the integration of the left side. Okay, integration of the right side. The integration of the right side, x squared y plus x. So we're gonna focus on the y. X squared integral of y dy plus x integral of dy. Okay, only two terms. We're gonna integrate that, x squared y squared over 2 plus xy. Okay, take note. Okay, take note. I'm gonna write the mdx here, and I'm gonna copy it below. Okay, take note. Okay, mdx and ndy has common term. Okay, so when we integrate mdx and ndy, we take note of the common terms. Basically, they are the terms that contain both x and y. Okay, and the g of x will be compared to the term that only has x on the opposite side. while the f of y will be compared to the term that only have y on the opposite side. Okay, because because there's no y term only on the opposite side, f of y is 0. And because we have negative x squared over 2, okay, on the mdx equation, okay, that's g of x, right? Okay, so the general solution of your equation will become, copy the common term, the terms we have common in the opposite equation, xy squared and xy, copy the terms, okay, copy the g of x and f of y, negative x squared over 2, then add c. So that is now your general solution. Let's simplify it further. Okay, simplify it further, multiply both sides by 2. Okay, taking away the x, so this will become x xy squared plus 2y minus x is equal to c. Okay, this is now our general solution. Okay, that is now our general solution, and this is the answer to our differential equation. Alright, we're gonna have a second part. So if you guys have learned from this video, I hope you guys learned from this video. So basically, this is a quick solution or quick how to solve on exact equation. I hope you guys learned something, and if you have any question, feel free to comment anything on the comment section below. Like and subscribe if you guys learned something. Okay, we're gonna do another exact equation for part 2. Okay, there are more ways to solve exact equation. This is just one way. Okay, and yeah, see you guys in the next video. Goodbye guys, bye bye, thank you so much for watching.